Hey guys, and welcome back. Let's continue now and create the flip source. I'm gonna call this flip source, and let's dive inside. We're gonna create an ocean source node, and this will allow us to set up the wave tank, the flat tank. And we're gonna change this to flat tank. I'm gonna use the size, the domain size that was set in the original file, which is about 40 meter in size. So here 42.5, 16, 45, 4.5, and currently it's not set to narrowband, so it's generating a lot of points, and that's pretty much it. I'm gonna create a floating copy of this. Now if we use the shelf to create the initial flat tank, it's gonna set and link all the attributes needed, but I want to do it by hand to show you guys where things are and how things are connected together. Now the first thing, as we all know, is that the domain of the flip solver needs to match the domain of the source. So I'm gonna copy this, set it to paste relative, copy this and set it to paste relative. I'm gonna link these guys as well, the fill volume, paste relative, and then use the narrowband feature. I'm gonna link it to here, and this is where we turn on the narrowband. So I'm gonna copy this, paste relative reference, and I'm gonna turn it on. Okay, now the other option that we need is the oversampling, and this can be found inside the flip solver under the particle motion. Where is it? Under receding, it's going to be oversampling. So this is this option here. We need to link to this guy, to this option, and then the particle separation is the particle separation. Okay, and the grid scale, we can link this as well. Cool. Now there's two more options that are a bit trickier, and this is where the shelf come in handy. The first one is the layer size. This is I need to show you the link, but basically the layer size is computed by multiplying the narrowband width option by the particle size and by the grid scale. So we have these two. I'm going to copy this and then multiply it by the grid scale. And this is from the shelf. This is how the shelf set it, and this is the correct one. And then the last one is from the flip solver narrow bandwidth. So let's find that. It's this one here. I'm going to copy. I'm going to paste relative just to get the link, and then delete this and set it to 0. Okay, and let's multiply this by that, and this is our layer size. Okay, the next option is the oversampling bandwidth, which is this one, and this is a multiplication of the grid scale, which is this option here, by the oversampling bandwidth. So let's find where that is. It's inside the flip solver, and if I go under the particle, it's this one, oversampling bandwidth. So I'm going to copy this and paste relative reference to get the link, and then delete this and then multiply this by that, and that's our bandwidth. We're going to turn on the scatter density to in case we wanted to increase the number of points, but we don't have to link it to anything here. And that's pretty much it. These are all the options that we need to check. Sorry, I changed. Yeah, sorry about that. This is all the options that we need to set and link. Let me double check. Yeah, that's pretty much it. And now let's link the flip object option. settings to read from the source. But first of all, I have one more thing to do. Now this node here is generating a surface and points, and we want to isolate them. So let's create a blast node and say if name equal surface, we want to isolate that. And this is going to give us the points. So let's create a null and call this out flip points. And then we need the surface field, and that's going to be the SDF. And this is very, very important. I'm going to copy this node and let's dive inside. So here we need to change this to narrowband and then set the SOP path to the points and then the volume to SDF. And now we have our scene set up and ready. So let's hit play. And I'm going to let this compute, and then we'll continue in the next video once I have